All right, so now we're moving on to exponential functions. And this is what this says. An exponential function is a function of the form f of x is equal to a to the x, where a is a positive real number that is not 1. So a is a positive real number. So an exponential function is a function of this form. Y is equal to a to the power x, and a is a positive real number. So a is an element of the set of what? Positive real numbers. All right, so that's important. So for exponential function, a is not going to be negative. It is always going to be positive. X, I'm guessing, can be both negative and positive. And x, I'm also guessing, can be what? X is a real number, so it's negative or positive numbers. All right, the first example, example 21, says sketch the graph of y is equal to 3 to the x. So what I did was I started off by drawing up a table of values. And from my table of values, I selected some values of x. Values of x from -3 to positive 3. So when x is equal to -3, 3 to the x would be equal to 3 to the, would be 3 to the -3, which is actually 1/27. This would be 3 to the -2, which would basically work out to 1/9. 3 to the -1, which would work out to be 1/3. And 3 to the 0, which is equal to 1. 3 to the 1, which is 3. 3 square, which is 9. And 3 to the 3rd power, which is 27. So from my table of values, I came up with corresponding values of x and y. Points to note, notice that there are no negative values of y. Even for values of negative values of x, there are no negative values of y. The lowest value of x, y I have is 1/27. So maybe it's a sketch, so nobody's asking you to draw a perfect graph. Let's try and give the best possible sketch that we can get. All right, there are no values of x, so I don't need. All right, my values of x are all right, let's not make it too wide. All right, we're going as high as what, 27? I know how much we should go by. No. Yeah, this would work. I could say 5, 10, 15. Don't necessarily have to get it perfect. 20, 25, 30. This is y. These are my x values. When x is 0, y is 1. So this would be 2.5. All right, maybe this wasn't the best value to go by. Might come back to it or not. Go by what? Definitely not 10. Nothing not coming to me. So I'm going up by 5. I'm tired. All right, so we should basically divide this area into 5 equal parts. All right. Nah, I'm actually not loving how this is going to look. So I'm going to revise this a little. All right. And say 1, 2, 3, 4, or maybe we should say 2. Now I want to go 1, 1, 2, 3, 4, 5, 6. So some of our numbers are not going to get included, but it's fine. When x is 0, y is 1. So this is a point. When x is 1, y is 3. So another point is about here. When x is minus 1, y is 1/3. It should be about here, 1/9. 127. So getting an idea as to how this thing is going to look. Right. Let's have one more try at it. All right. One more go. It is a sketch, so perfection is not really expected. All right, so it's something like that. All right, and this would be my graph of y is equal to 3 raised to the power x. So we're asked to do a sketch, and a sketch is what we did. All right, let's see what follows. All right, here are some observations from what we just drew. One observation is this, that notice that 3 raised to the power x is always greater than 0. That's an observation, that for all values of x, 3 to the power x is always greater than 0. If something is greater than 0, it means that it's never negative. And we can look at our table of values. We have positive 1/27, 1/9, 1/3, 1/1, 3, 9, 27. 3 raised to the power x is always what? Positive. And I think I said this earlier, that you can never raise a positive number to a power for it to become negative. You can never raise a positive number to a power and the answer comes out negative. So 3, which is a positive number, raised to any value of x will always be positive. It will always be greater than 0. So 3 to the x is always greater than 0 for all x. Therefore, the range of the function is from 0 to positive infinity. In other words, the values of y will go from 0 to positive infinity. Now, the graph has no x-intercepts and lies above the x-axis. Now, regardless of how low the value of yx is, or how far you go back in terms of the value of x, this graph will always get closer and closer to the x-axis, but it will never touch it. Now, the x-axis is the line y is equal to 0. So y is equal to 0 is something that we call an asymptote. We'll come across the term again later, but essentially an asymptote is a line that a graph approaches, but it never ever what touches. So the x-axis, which is the line y is equal to 0, is an asymptote. It means, therefore, that the graph y is equal to 3 to the x will approach the x-axis, but it will never touch it. So because it will never touch the x-axis, there is no x-intercept. The graph will always be above the x-axis. Now, as x approaches negative infinity, f of x approaches 0. All right, so you'll hear somebody said that if 3 to the x is equal to 0, x would have to be equal to what? Negative infinity. All right, which is why we don't talk about the logarithm of 0, because the logarithm of 0 is negative infinity. So as x approaches negative infinity, 3 to the x approaches 0. As x gets closer, as x gets more and more negative, the function approaches 0. Now, you can also notice that as x gets closer to positive infinity, 3 to the x gets closer to infinity.